Assalamu alaikum everybody, this is Imad Abdulaziz Bamatraf.
I'm Ahmed Shafiq bin Muhammad Anwar.
I'm Abdullah Abdel Nasser Bawazir.
And today guys we're going to talk and explain about our design project, which is making a regulated DC power supply. Fixed dual actually. That means having positive and negative value. So
Let's go.
let's go.
A transformer can be defined as a device that helps transform electrical power in 1 second into the same frequency electrical power into another second, but the voltage is increased, same, or decreased from the previous second. A transformer has primary and secondary winding, which determine the voltage for the next second, whether it is increased or same or decrease. In this project, the voltage has been decreased from 230 volt into 24 volt, as the primary winding of the transformer used in this project is higher than the secondary winding. This is called a step-down transformer. The transformer also used to split voltage equally to half wave in full wave rectifier. The basic equation of transformer is Vs over Vp equal to Ns over Np. A full wave rectifier is a circuit that uses AC voltage as an input and convert into DC. In this rectifier, two diodes are used for each half wave. In a half wave cycle, one of the diode will become forward bias and another one will become reverse bias. The equation of the full wave rectifier is VDC equal to V peak over pi. Electrolytic capacitor is a type of capacitor that uses an electrolyte to achieve large capacitance than other capacitors. The use of this capacitor in this project is as a filter to stabilize the DC voltage. Voltage regulator is an integrated circuit that can be defined as the component that regulates the voltage level. It generates a fixed output of the voltage that remains constant for any change in an input voltage or load condition. In this project, there are two types of IC voltage regulator, which is 7812 and 7912. The series 78 and 79 means the output voltage will become positive and negative respectively. The number 1 and 2 at the last part of the series of the IC voltage regulator means the voltage regulator will be produced 12 volt of the voltage.
Before we do the fabrication and the etching process or any other process, we need first to print our design, which is this one. As you can see, this is our design for the voltage regulator, and we need to print out this PCB layout. Once we print this PCB layout, we're going to move to the UV light room. I'll show you. Once we printed out our PCB layout, we're going to move to the UV light room. So, as you can see in this room, we need to put the copper and the PCB layout on top of one another and put it right here. And then once we close this part, we need to turn on all these buttons and make sure the timer has to be like 10 seconds in order to move or to copy the layout onto the PCB board. Yes. So once we do this part, we go to the fabrication and etching process. Okay, once we're finished from the UV light room, now we're going to move to the fabrication process in this room. Follow me. So basically, etching is traditionally the process of removing the unprotected surface of the metal. So in our case, we're going to use the etching process to remove the unprotected part from the PCB layout. So we want to first we need to use this. First we need to never mind that. Okay, first we need to do this. We need to put our PCB board into this chemical acid, chemical solution. Okay, we need to soak this for 6 to 10 minutes, 10 seconds, sorry, 10 seconds. Then after this, we need to wash it with the water. If we see that it's completely removed, then we move to the another process, which is it's either this one or either this one. So we need to put our PCB board here for around 3 to 4 minutes maybe. Also, it's kind of a chemical solution to remove the unprotected part as well. So once we finish from this part, we need to wash it again. So once we wash it again, we put our PCB board in the last chemical solution, which is it's kind of like an acid, like, if I'm not mistaken. So this part, yeah, we need to put it here, okay, and maybe for around 10 seconds, if I'm not mistaken. Yes. Then we wash it with the water. We need to make sure that the pattern that we already printed out is on the board after we finish from all processes. So if there is a green part, a greenish part in our, how do you say, in our layout, we need to repeat the last process many times until we see the road, the layout. Yes, the layout is a golden, yeah, it's golden color. So if it's a golden color, that means it transfers the electricity. I mean, there is a connection. The connection is good. So once we finish from all the fabrication etching process, we need to dry it out using this kind of machine. Finish from the etching process and everything, we need to dry our board so we can use it using this machine. So we put our board here, then we get it from the outside. It only takes few minutes. So now let's move to the drilling part. Now after finishing from the etching process, we use this kind of machine to drill the holes in our board in order to connect, to place in our components. And then after we finish from this part, we go to that lab, to that room, specific room, in order to solder our components correctly. So this is the soldering room where we solder our parts, our components in the circuit. So this is our classmate is currently soldering our components onto our PCB board. after it has been drilled. Yeah, so after he finished from the soldering part, we're going to show you guys the results, the practical and the multi-sim results, so we can compare and show you our work. Okay, this is basically our circuit diagram for the voltage regulated DC power supply fixed dual, meaning that we're going to have positive output and negative output, and both of them are fixed. And for our, we just chose 12 volt. So at the beginning, we're going to connect our circuit, our transformer specifically, with the AC. So the AC value is going to be any socket which is provided in our house, 230 VRMS. So our transformer is a step down transformer, which is going to step down from 230 VRMS into 24 VRMS. And this is the formula we use in order to make this happen. So next, we connected the transformer with a full wave rectifier, meaning that we used a 4 diode and this kind of connection in order to cut the lower part, which is this part exactly. We want to remove this one. So the effect for the full wave rectifier is like making the upper part of the waveform like going to be repeated, and this is the output for the full wave rectifier. So this is actually the effect of the full wave rectifier is to provide a DC, but in this case, you can see this is it's like half of the sinusoid. So we want to remove the sinusoid. In order to remove the sinusoid, we used a capacitor, and after we used the capacitor, the effect happened to this waveform is like this. So we can see that there is a DC value, but it's yet not regulated. So there is a ripple, like a minor problem here. It's like there is a ripple in here, and in order to get rid of this ripple, we use the voltage regulator. This one and this one. Now to get the value for the VDC, for this part we use this formula, which is VDC equal to 2Vm over pi. The Vm, the one we get from the transformer. So yes, after we connected the capacitor with the voltage regulator, we get the output for the output of this component, the VDC, and it's fixed and regulated. Previously, it was not regulated because of the effect of the capacitor. But once we put the IC for the voltage regulator, it has been regulated and provided both positive and negative fixed dual value. Okay, as we can see here in the oscilloscope, when we connect this cable with the positive output, this is the waveform that we get. It's equal to 12 volt, 12 volt around something. This one is the input power. So to check more, when we connect the multimeter with this one is a positive and this one is the ground. So when we do the correct connection, we get this value, which is 12 volt point, almost 12. It's 12 volt, yes. Try to connect to the negative part. For the negative part also we get the same value, only differ a little bit, just a tiny difference.